Think about it. What can soy, and the crop is soy, the previous crop was maize. What can soy make for itself that weeds cannot? Nitrogen. Nitrogen. Maize has for a large plant, has a very small root system. If you leave it in the soil and rotate to soy the next year, there are several things that happen that are bad. One is that the soy, which could be making free nitrogen, soybeans are just as lazy as us. If the nitrogen is there, they're not going to work to produce anymore. They're going to use what's there that you paid for, instead of working and making free nitrogen for you. The other thing that happens is the nitrogen will also grow weeds. So if you use a winter cover crop to suck up that nitrogen, hold it in the form of that mulch, it's held away from weeds, and your soy doesn't care. It makes its own. And it will make more nitrogen than it would otherwise. So next year, your crop, after the mulch rots down, it releases the nitrogen it held earlier, plus the soy made more. So you get more total nitrogen in your system, which is good if your next crop is a crop that needs nitrogen. And you say, this works great if my next crop is soy, but what if my next crop is maize, which needs a lot of nitrogen? Remember the picture I showed you of the hairy vetch that was killed with a roller crimper, planted maize into it? Hairy vetch is a legume. It makes nitrogen. You say, well, doesn't that make your weed problems worse? No. Because where is the nitrogen in this field right now? It's in the mulch. It's going to be in the form of protein in that mulch. Only after that mulch decays will the nitrogen be available to the next crop. So there is a time period in there where there is no nitrogen available to the maize. How do you make sure the maize has adequate nitrogen but the weeds don't? You use a starter fertilizer next to the row. A very small amount of nitrogen placed where the maize can get it, but the weeds can't. You don't broadcast the nitrogen, you place it only where the maize can get it and keep it away from the weeds that are between the rows. It's a very effective method of weed control. This farmer uses no herbicide. All of his weed control is done with cover crops. Hey, once you have the water in the soil and you prevent evaporation, you need to have a soil that holds on to the moisture. This picture, you can see the farmer is standing in dead maize. Why did the maize die? Didn't rain. Same farmer, same Pioneer hybrid of maize, planted on the same day in the field right across the road. So same rainfall, same soil, same management, same hybrid, same everything, except this field was treated a little differently. In the 1980s, we had a government program that paid, crop prices were very low, so we had a government program, and our soil erosion rates were very high. So we had a government program that paid farmers to plant fields back to native grassland, called the Conservation Reserve Program. This field was enrolled in that program and grew native grasses for 20 years. Has anyone taken a field of veld and converted it into crops? What does that field that has been in veld for a long period of time have more of in the soil than a field that's been cropped throughout history? Soil organic matter, carbon. And if you look, I apologize for the English units on this. This is the way, the only form I could get the slide. But as you see, it doesn't matter. If you see the percent soil organic matter to the left, and you go across, look at 1% soil organic matter on a silt loam. 1.9. Now look at the same soil with 5% organic matter. The soil water holding capacity is doubled. Double. Your soil can hold twice as much moisture, and it can get recharged after each and every rain and hold twice as much water, which means you can go twice as long between rains before your crop begins to suffer. So increase the soil organic matter. Why do our soils not have the organic matter we like? It's because of tillage. The more tillage we do, the less organic matter we'll have. Take a look at this. This is the pounds, it's pounds per acre. If you want to convert pounds per acre to kilos per hectare, take it times 1.1. As you can see, the far left column is moldboard plow. And in the middle, we have disking, chisel plowing, other forms. The bar at the far right, the very short bar, is no-till. This is the organic matter loss within 19 days after the tillage trip. Look at the moldboard plow. In this study, almost 4,000 kilos per hectare of organic matter were lost due to one trip with a plow. These two maize plants, this is one of my neighbors. Both of these plants were grown with full irrigation, full fertilizer according to soil tests, the best of modern knowledge. Why is one twice the size of the other? Same hybrid. These plants were taken 3 meters apart. Managed the same, except the soil was slightly different. This was once a gravity irrigation field, and he put in a center pivot. And because of the center pivot, he was able to irrigate 1 extra hectare. This extra hectare had been a native grassland, had never been plowed ever in its life, and was terminated with glyphosate and planted no-till. Still, even though growing crops, has never ever been plowed in its life. And look at the difference between those two plants. The one in the right came from that old veld that has never been plowed, never had grown crops before. What is the difference in the soil between the one on the left that's been farmed for 150 years and the one on the right? It's not fertilizer and it's not water. If I ask you, what does soil provide for the plant? You say water and fertilizer. This is something different. I don't know what the difference is. Because everything I learned in college tells me that the plant on the left should be the same size as the plant on the right. But there's something more. Something I wasn't taught in college, and that's soil biology. There's something about the soil biology that's different, that is making the plant on the right twice as big. And when I rode the combine with this neighbor, because I wanted to see the results, and the yield monitor on the combine, the yields on the right were 50% higher than the yields on the left. It's amazing. That much difference, even though he provided all the water and all the fertilizer that the plant on the left required. The best way to increase soil organic matter, you saw that having perennial vegetation, veld, that soil had higher organic matter than one that we had managed. How do you restore that soil organic matter? The best way is to plant perennials. Why perennials? And a mixture of perennials. Have a lot of diversity. Grasses, legumes, and forbs, like here. Why perennials? The root system on the right is the root system of wheat, winter wheat. The root system on the left is a plant closely related to wheat. In fact, they can be hybridized. But it's a perennial, intermediate wheatgrass. Look at that, 3 meters versus 1 meter. And one other very important distinction. How many months out of the year does the root system of wheat look like this? 1, 2. How many months out of the year does wheat have no root system? 5, 6. There's months where there's no root system at all. How many months out of the year does the perennial have a root system that looks like this? Every month. Every month. And we'll talk about why that's so important and how we can mimic that system. It's also very important to have diversity. And this is a diagram of the root system of the prairie where I live. You can see there are grasses with fibrous root systems, and there are forbs and legumes with very deep tap roots that go below the root system of the grasses, and so they don't compete for water. Now you can also see that they can explore and take up minerals that the grasses cannot access. But it's more important than that. It's more important than water, it's more important than minerals. Because when you have a diversity, you get different root exudates. I'll show you a picture of the root exudates as they happen. But when you combine all these different species, the grasses, for example, have root exudates that are high in sugar. Legumes have root exudates that are high in protein. Forbs have exudates that are high in minerals. And some, like sunflower, is able to access zinc. Buckwheat is able to access phosphorus. And Phacelia is able to access potassium. Different plants are able to access different things. They add that to the root exudates. And remember, you feed your soil microbes the same way you feed cattle. You give them a balanced diet. You give them carbohydrates, you give them protein, you give them minerals, and they grow faster. And so do your soil microbes. So when you have this diversity of roots, you get more microbes. And more microbes means more yield and more efficient crop production. If you add cover crops to a crop system, now obviously the fastest way to build soil organic matter is to plant perennials. But if you want to crop, how do you do it if you still want to raise maize, soy, wheat? You add cover crops to the system. This is the same study I've been referring to before. Look at how much higher the bars are for soil carbon where you add the cover crops. When you add cover crops to the system, you add more root exudates and you get more microbes that make organic matter. One of the best, this is sun hemp. This field where this sun hemp is growing has never successfully raised a maize crop to maturity. Ever. Too sandy. Just pure sand. This sun hemp was actually grown after a crop of wheat. This photo was taken 90 days after planting, right before our frost. This is another field, another cover crop. This is sorghum Sudan. You can see the short guy in front. Look at this biomass. Look at that biomass. Isn't that impressive? Think what happens when all that growth is returned to the soil. How many microbes that can feed. Now, unfortunately, all of that top growth does very little to increase soil organic matter. This is where organic matter is made. This is the root exudates I was talking about. Look at the way little droplets of very high sugar water, protein water, mineral water is going out of the tip of that root. Isn't that amazing? This is where 85% of your organic matter is made. Not from the top growth, only about 15% of your soil organic matter comes from top growth. 85%, roughly, comes from this process. This feeds the soil microbes that make soil organic matter. So if you look at this cover crop, this is beautiful. You have all this growth above ground. And you look at this and you say, what a waste that this does not also contribute to soil organic matter like the root exudates do. What if there were a way to make this? And why doesn't it? The problem is that it takes microbes to make soil organic matter. You need the environment for the microbes. Microbes, have you heard about the coronavirus? No one's heard about coronavirus? It's all we hear about. And they say one of the ways that coronavirus is killed is by sunlight. Ultraviolet radiation in sunlight. Sunlight is a great sterilizer. That's good if we're talking about coronavirus. That's bad if we're talking about soil microbes. Soil microbes cannot function where they're being constantly bombarded with ultraviolet radiation on the soil surface. They need it to be dark, constantly dark, warm, and moist. Does that describe the soil surface? No, not at all. That's why most of the soil organic matter is created underground. I just wish that I had a machine that could take the high energy of that sorghum and combine it with the high protein from that sun hemp or that cowpea and the high mineral, the zinc from the sunflower and the phosphorus from that buckwheat, and combine it all together, mash it together and grind it, because it has to be in close contact. Because a microbe can only travel maybe a millimeter in its entire lifetime. So it has to be, everything needs to be mixed together and ground finely. And this machine would take and do that and put it into a warm, moist, and dark fermentation vat for about 48 hours and spread it out onto the field. And I would have this machine be solar powered because I'm a green environmentalist. And I would have it have a 3D printer that makes its own replacement at the end of its life cycle. And I would have it recyclable because, again, I'm a green environmentalist. So I want it to be recyclable. In fact, let's have it so we can recycle it into human edible protein that is so delicious we build restaurant chains around it. And this is the machine that does that. The machine that makes this does all those things. That's why livestock are so critical. And I think it's sad that so many people who are concerned about the environment believe that the way to save the environment is to remove the cattle. No, no, no. We need more cattle on the land, but managed properly. Because it's only through passing all that material through a rumen can you make this. This is nature's perfect soil improvement medium. It also is what pays for the cover crops that are so crucial. Grazing cover crops pays for them. So that now you are making money from doing the right thing for your land. What a great deal. There is this perception that farmers rape their land, they destroy their land, they pillage their land for money. No, you make more money by treating your land correctly. And this is the way of treating your land correctly. Every hectare should have a ruminant animal walking on it at some point in time. Because this builds soil from above ground biomass the same way root exudates build your soil from below ground biomass. The other way to build that soil organic matter is mycorrhizal fungi. See those white threads? That's a fungus that colonizes the yellow structure there is a root. It lives partially inside the root, reaches out, it brings water, and it brings nutrients back to the plant. greatly increases drought tolerance. You can see the healthy maize was inoculated with mycorrhizal fungi. This drought-stricken maize was not. Very important for bringing water and nutrients back to the plant. This is oats. To the left of this woman was not inoculated. To the right was inoculated. But more importantly, take a look when I show you a close-up of the roots. The plant on the left was inoculated. See how much darker it is? How much better aggregated? That was inoculated. The mycorrhizal fungi, as they go through the soil, have a lubricant called glomalin that is also a very powerful soil aggregating agent. It makes your soil better, and it's also very persistent. Lives as long as 40 years in the soil. That is long-lived soil organic matter. Okay, so as we began, they were telling me, it doesn't rain every day. It rained because I came here, by the way. For a small fee, I'll come again. I would love to come again, by the way. I have thoroughly enjoyed my time in Africa. And the scenery is beautiful. The places I've been, just gorgeous. But the thing that really has made Africa for me is the people. I've felt so welcomed. And everyone I've met has been so wonderful. It's other than the person who stole my cell phone at the airport. That guy, I'd like to see him again. Everyone else has been great. But you told me that this is a dry area. And I come from an area that's historically dry as well. And when my ancestors came to the area, there was a government program. Now, so many of my disaster stories start with a government program. I don't know why. But there was a government program, and it sounded great. We're going to give free land to people. And we'll make our people prosperous because they'll have free land. The problem with this is that the rules of the program were written by a person on the East Coast next to the ocean in Washington, D.C., where it rains. 1,000 millimeters of rain a year. These people moved to where there's 300 millimeters of rain a year. And they were given 50 hectares of land, and you had to make a living off that land. You had to build a dwelling. You had to plow all the grassland because it was, at that time, it was considered your duty as a good Christian to plow as much land as you could. I don't understand that, but that's what the feeling of the time. And you had to successfully raise a grain crop 5 years in a row to prove your value to remain on the land. 300 millimeters of rainfall. How many people made it? Only 20%. 80% failed to make it their first 5 years. Because even now, with all of our technology, people can't raise a grain crop in 300 millimeter rainfall every single year. So they developed this system called fallow. Fallow. We plant nothing for a year, and we keep it tilled because what we're going to do is we're going to store all the moisture that occurs during that fallow, and we're going to add it on to next year's rainfall, and we're going to raise a crop. Here's the problem. What percent of the rainfall that occurs during that fallow period is stored? And our typical fallow is 10 months. And now we do no-till fallow. Under tillage, only 10% of the moisture that occurs during that fallow is stored. Under no-till, only 25%. How efficient is this? Now think about this. Well, I'll show you. Here's how the system works. You get 400 millimeters of moisture a year, let's say. You store 25% of that, and that's under no-till. So 100 millimeters of that, you add that on to next year's rainfall and you get a good grain crop. because 500 millimeters is far better than 400. But how did we accomplish this? We took 800 millimeters of our most limiting factor and changed it into 500. How intelligent is it to get rid of 40% of your most limiting factor? It's stupid. As a farmer, you get two things for free. You get sunlight and you get rainfall. During that fallow period, I've already showed you that you waste 75% of your rainfall. What percent of your sunlight do you waste? 100. All of it. You waste all the sunlight. I saw a presentation by a young man named Jason Mott, and what a breath of fresh air. He really changed my thought process. He showed a picture of a 6-ton wheat crop on June 21st, ready for harvest in our area. He said, "Is this farmer doing a good job?" Everybody goes, "Yeah, 6 ton of wheat is tremendous yield." He goes, "No. Your job as a farmer is to harvest sunlight. You're not here to grow wheat. You're here to harvest sunlight and change it into something useful." June 21st is our summer solstice, the highest sunlight day of the year in the northern hemisphere. And that field was performing 0 photosynthesis. Wow, you're right. You think about this, fallow waste 75% of your moisture and 100% of your sunlight. It's stupid. So how do we do something different? Fallow doesn't rest our soil. Think about, not only does it waste sunlight and it wastes water, but it also starves our soil biology. We lose our biology. It gives us drought tolerance, gives us soil organic matter, all those beneficial things we want. So,